Good day, grade 10s. I trust that you all are well. Today we're looking at some algebra revision, so please take out your revision document, the one that says grade 10 Maths November exam revision. Okay, so we're going to start on page 1 of 16. You must please do the maths yourself, right? You can't just learn maths by looking at somebody else do the maths. You got to do the maths, challenge yourself, push yourself, do some extra past two papers, and this is how this revision program will be successful, right? At the top of the page, page 1, you have your scope, telling you what topics are in paper 1, what topics are in paper 2, as well as the mark allocation per topic. That's important because the mark allocation will dictate how long you're going to spend per topic. Alright, so make sure you take a good look at that. So today we're going to look at question 1 to 4 of the revision program. Now learners, I have to give you a little bit of a heads up. I'm not the best at technology, so you expect a glitch or two along the way as I attempt to do this program. Also, please ignore the writing. Using a stylus pen to write on the tablet that I'm using is not the best way to write. Okay, so it's going to be a little bit untidy, but please bear with me. I will send you well, I've already sent you the answers on a document, so that's clearer if something is not too clear for you. Right, let's try our best though. Okay, so today we're looking at topic 1. Before we get into it, let's look at some revision of some grade 9 topics of number systems. Okay, so when you look at number systems, we're going to start with the basics. We're looking at natural numbers, all right? Natural numbers. So that's like counting numbers. If you were in class and I begin to count the learners, you start with 1, 2, 3, and you move on, and we'll go up until positive infinity there. The next category is whole numbers, starting from 0 all the way up until positive infinity as well. And then the next system is integers. Okay, this is all negative numbers, 0 and positive numbers. So another way from negative infinity to positive infinity. So negative 50, negative 25, negative 5, 0, 1, 10, 200. You get the idea there, right? There's no decimals included here though. And that's important because that brings us to our next category. Next, we're looking at the real number system, and the real number system is split between two categories, and that's rational numbers and irrational numbers. We use a Q for rational numbers and a Q with a little apostrophe at the top for irrational numbers. Let's look at what categorizes rational numbers. If we look at the first fraction here, a rational number is a fraction where both the numerator and denominator are integers. So 1's an integer, 2's an integer, that makes that rational. The second fraction there, minus 3 is an integer, 2 is an integer, hence it's rational. Then all integers are rational. So if I have, let's take 5, if you put 5 over 1, because remember you can put any number over 1, right, and it doesn't change its value. The 5 is rational, the 1 is rational. Okay, for number 3, we're looking at something called recurring decimals. Okay, that's denoted with a little dot at the top of the number. That means that number recurs. Or I could give it to you like this, right? 0.311111, and those 3 dots there means that that pattern continues. So recurring decimals are rational. Lastly, number 4, this is what we call a terminating decimal, meaning the decimal ends, right? It terminates. You can see it doesn't go past 8, right? It stops at that point. So all decimals that end are rational. That brings on to the next set, which is irrational numbers. So if you look at number 1 for the irrational number, 1 is an integer, but if I put root 2 on the calculator, I want to get 1.41 and a few other decimals. Now that decimal is not an integer, right? Root 2 is not an integer. So because the denominator is not an integer, therefore it's irrational, right? This symbol, yeah, pi, which is in fact 22 over 7, pi is irrational as well, okay? The next thing is surds. Surds are the square root of non-perfect squares or the cube root of non-perfect cubes. Basically, if you put these, let's take root 8. If I put root 8 on the calculator, I'm getting a decimal. So if you can't get a whole number when you put in a root, if you don't get a number, if you're getting a decimal, then it's a surd. If let's try cube root of 15, right? If you put cube root of 15 on the calculator, we're getting 2.47, and that's a decimal, so you don't want that. So if you can't find the root of it, if you're getting a decimal, it's a surd, right? And all surds are irrational. Number 4, we're looking at this decimal over here, and you'll note these 3 dots which indicate that this decimal does not end. In other words, it's non-terminating, and non-terminating decimals are irrational. Okay, I hope you've understood the concept between irrational and rational. There's a few more concepts we're going to focus on. If you are asked when something is undefined when it's divided by 0. Okay, you can't divide by 0, it's going to be undefined. However, you can take 0 and divide it by a number, the answer will be 0, but 0 can never be a denominator, right? Okay, the next thing is non-real. So we know that we get the real number system, but what are non-real numbers? Well, that's the even root of a negative number. For example, the square root of -4, the fourth root of -7, and so forth. If you put this in the calculator, you get maths error, but when you are in your exam, the answer is never maths error. If you get a maths error here, it's just going to be non-real. Okay, when you're looking at non-real, remember it's the even root of a negative number. And if you think about this logically, there are going to be no two numbers that will multiply by itself to give you a negative. So this makes a lot of sense if you think about it. All right, let's go to page 1 of 16. I'm on question number 1.1 that says, if x equals root 2 and y equals -2, determine whether the expressions are rational, irrational, or non-real. Okay, they're not asking us about integers and natural numbers. They were quite specific on what they wanted here, right? I'm just going to change the color of my pen. All right, so the first one is x times y. So this is basic substitution. Where I have x, I'm going to substitute the value for x, which is root 2. And where I have y, I'm going to substitute the value for y. And then I multiply that, I got -2 root 2. Now let's look at this expression. Is this rational, irrational, or non-real? Well, I know there's root 2 there, and root 2, I can't find the root of that. So it's a surd, and all surds are irrational. All right, let's do the next one. 1.1.2, 1 over x. Well, x is root 2, so this is now a fraction. 1's an integer, but root 2 is not an integer. At the moment you have a fraction where either the numerator or denominator is not an integer, then that's going to be an irrational fraction. All right, let's look at x squared, number 1.1.3. If I take root 2 and I square it, the square root is cancelled by the square. I'm left with 2. 2 is an integer, and all integers on its own are rational. Number 1.1.4, I have root of y. So y is -2. Okay, if I look at this, the square root of a negative number, I know that doesn't exist. It's non-real. Right, let's go to the next one. The next question, number 2, says if k is -4 over x minus 2, determine the values of x. Right, so this is the possible options of x. Determine the values of x where x is an element of real numbers. The subset of x is 1, 2, 3, and 4. So from those options, we need to know for which values of k, for which values of x, sorry, will k be firstly undefined, irrational, or non-real. When you get these questions, you're going to go to your calculator. The first thing I want you to do is take each of these numbers, each of the possible values for x, and sub it into the equation. So you got 4 over 1 minus 2, and you can do the rest on the calculator, right? So when I put 4 over 1 minus 2, let's just quickly punch this into the calculator. We're getting an answer of 2. All right, When we substitute x, so when we put minus 4 over 2 minus 2, that becomes 0 at the bottom, so that becomes an undefined answer. Okay, when we put in 3, we're going to get in the square root of minus 4. Okay, this one you're going to have to do that mentally, right? You can't use the calculator for that. When I put in 4, we're going to get the square root of minus 2. This one as well, you're going to have to work that one out mentally. Okay, so 2.1, when do we have an answer that's undefined? Okay, and we got a value of k that's undefined when x equals 2. 2.2, when did we get an answer that's irrational? Well, when I look at it, no value of x gave me an irrational answer. So I'm going to say no values of x. When did I get a non-real answer? Well, that was when x was my root 3 and when x was 4. So x equals 3 and x equals 4. Okay, let's go on to number 3. The question says rewrite 0.17 recurring as a common fraction. Okay, so this approach is simple. Firstly, we're going to take what's in the question and we're going to say let x equals 0. Okay, remember now the 7 is 77777 and that continues. All right, and I'm going to call this equation 1. Now the rule is simple. You're going to multiply such that one set of your non-recurring decimal moves to the left hand side. So there's only one decimal that's not recurring, and that's the 1. So to move the comma once, I'm going to take equation 1 and I'm going to multiply it by 10. If I do that, I'm going to get 10x equals, the 1 will move over, 1.7 recurring. Okay, if you wanted to, you could have put 777 and the 3 dots, right, or the ellipsis. Let's call this equation 2. Okay, next step, you're going to multiply such that one set of the recurring decimals move to the left hand side. So I only have one recurring decimal, so I've got to just move 1 across. So to move 1 across, I'll multiply by 10. If you had two numbers that's recurring, like let's say 7, 3 recurring, then you're going to multiply that by 100 so that it moves twice and you get the 7 and the 3 across. Okay, so I'll take equation 2 and I'm going to multiply this by 10, and that will allow me to move the 7 across. Okay, so we'll have 10 times 10, which is 100x, equals 17.7 recurring, and we're going to call this equation 3. Now that we've moved one set of our recurring and our non-recurring, we're going to take the last equation, subtract the second last. So we're going to take 100x, subtract 10x. That's going to give us 90x. And we're going to take 17.7 recurring, subtract 1.7 recurring. So the 7 recurrings are going to cancel. And 17 subtract 1 is 16. Okay, we'll just erase this. Alright, so we got 90x equals 16. So we're going to solve for x. X equals 16 over 90. And that's 8 over 45. You can always double check your answer for this question. So if you go to your calculator and you type in 0.1 and put 7 a bunch of times, add as many as you can. When you press equals 2, it gives you a decimal. Just press SD and it does give us the answer of 8 over 45. So I know this answer is correct. The next question is estimating surds. Okay, when we are estimating surds, we're also going to use the calculator for this one, right? So go to your calculators and just put in the what's in the question. So this question can ask you between which two integers does the surd lie. You're going to give these answers They may also ask you to express it on a number line. So if you go to your calculator and you type in the cube root of 45, it gives you an answer of 3.5. So that means the final answer is 3 is less than the cube root of 45, which is less than, okay, and the next number after 3 would be 4. Okay, now this is the final answer. We gotta go back and show some working out. Okay, so 3 cubed is 27. We keep what's in the middle the same. And 4 cubed is 64. And then you're also going to find the cube root of both sides. And that gives you the answer that we have. Okay. Let's do one with the negative. So if you go and you punch in the square root of 12, the answer is 3. The next one will be 4. But you're going to multiply that by negative, and that will give us -4. You always put your smallest number first. Okay, let's take this back now. So it'll be minus 4 squared is 16. Keep this one as is. And 3 squared is 9. Alright, there's the answer there.